This is a cat and this is a dog. I could show you 1,000 of these in different scenarios and you'd still know which was which. It's easy now, but you couldn't even start to do this until you were 3 to 4 months old. And that is why it's so awesome that we taught artificial intelligence to do this task. But how does AI do this? Once you understand the math behind it, it's not that mysterious. So let's take a look at one of the fundamental forms of AI, artificial neural networks. Artificial neural networks are a collection of neurons, kind of like the ones in our brain, divided into layers. The input layer, which takes in data, the hidden layers that perform a set of calculations, and the output layer, which makes a decision, like, yeah, that's a dog. These layers are connected through mathematical relationships that enable the network to think. Each neuron receives its input from the past layer and applies its weights and biases through multiplication and addition. Weights and biases are like a neuron's personal opinion, such as sharp edges could be pointy ears. Now this equation here is the equation of a line. This line separates cats from dogs in our feature space, the multidimensional space in which our input data exists, which is a fancy way to say all the cats and dogs and their defining characteristics. The goal of training our network is to draw the line that most accurately separates our two classes, cats from dogs. Sometimes a single rigid line can accurately separate the classes, but other times it's complicated. And that's why artificial neural networks are so cool. They can find the boundary between classes even when a single straight line can't do the trick. How? By bending it. They do this through activation functions, which are really just a set of mathematical operations like the multiplication and addition earlier. Activation functions are applied to each neuron's output before that calculation moves to the next layer, turning our rigid line into a bendy one. But what if even a bendy line can't separate all cats from dogs? Then we try a different strategy. We fold our feature space. While the network cannot draw lines separating cats and dogs at this point, after a few folds, we can clearly separate cats from dogs. Here's the math origami happening behind the scenes. Each layer of neurons receives its input from the last layer, applies its calculations, and passes it to the next layer. By adding more hidden layers, we expand the equation that tells our network how to classify cats and dogs, so that by the time our input has made it to the output layer, our network is sure that this is in fact a dog. And that's the fundamental math behind AI. Draw a line, make it bendy through activation functions, and fold the feature space like origami until a clear boundary emerges between cats and dogs or any set of classes. This is the basis for the AI behind everything, from self-driving cars to cancer diagnoses, to facial recognition, to the Alexa on your kitchen counter. So next time you hear AI, don't think Terminator, think math.